Assalamualaikum and salam sejahtera to Encik Saifullah. So this is our project assignment for electronic system. We are from 2BEZ. Okay, first let me introduce my group mates. Me, myself, Nurni Lamsari, Mustafa Hazim, Mahram Mahazen, Muhammad Amiruddin, Muhammad Fahmim, Revaiti, Siti Khatijah and Suying Sen. So we will discuss about electronic system in many content. First, we go to introduction. So, an electronic system is a physical interconnection of components or parts that gathers various amount of information together. It does this with the aid of input devices such as sensors that respond in some way to this information and then use electrical energy in the form of an output action to control a physical process. So, I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Ramli and I will present about the oscillator 1. The oscillator for oscillator is a circuit which produces a continuous repeated alternating waveform without any input. Oscillator basically convert unidirectional current flow from a DC source into an alternating waveform, which is of the desired frequency as decided by its circuit component. This is the example for calculation of oscillator. We use the formula frequency response 1 over 2 pi RC. Next. For the simulation and output waveform, we use multisim software to design a circuit for oscillator 1. And we use to produce the frequency 1 kilohertz using using oscilloscope. Okay, that's all from me. I will pass it to the other group member, Siti Khadijah, to explain about oscillator 2. Thank you.
Thank you, Fahmim. So my name is Siti Khatijah binti Maintan. I will proceed with the presentation about oscillator 2. As you can see, we are also using the same equation, which is Fr equal to 1 over 2 pi RC. The Fr is given and value is 20 kilohertz. And we assume the value of R, which is 600 ohm. So after we calculate, we get the answer is 13.26 nanofarad for capacitor. And the voltage gain is we are using the equation of voltage gain is 1 plus RF over Rin. So the value of RF is 700 ohm and the value of Rin is 450 ohm. The answer is 2.56 for the voltage gain. So here is the circuit of oscillator 2, and at the right is waveform of oscillator 2. The wave will show is straight line because the voltage is too small because it in milli. So the wave that's why the wave in straight line. But we still get if Fr is 20 kilohertz. Thank you. So I will pass the presentation to Mahran.
Thank you, Katie. Assalamualaikum warahmatullahi wabarakatuh. My name is Muharram bin Mazil. Today, my part is to explain about simulation and output waveform for summing. This is for circuit diagram for the summing, which is we use from oscillator 1 and oscillator 2. Okay, this is a oscilloscope waveform that get we want to get the waveform. Next, okay, this is for calculation for summing oscillation 1 and oscillator 2, which is use V out is equal to V in plus V2, that we get the result is 14 volt. Okay, that's all from me. Thank you. Now I would like to pass to Mustafa Azim present his part.
Thank you, Maran, for the presentation for something. Now I will present my part: active low pass and active low pass filter and rectifier. Active low pass filter are made up of OM. The input of the OM is high impedance signal, which produce a low impedance signal as output. The performance of the amplifier play a very important factor when designing an active low pass filter. This is the calculation for our active low pass, which we will require to achieve a cutoff of frequency cutoff of 8 kHz, and we decided to use 22 nano for our capacitor. For the formula for the frequency cutoff is shown as 1 over 2 pi RC, where we have inserted the 8 kHz value and the capacitor value, and in the end we got the value resistor of 904 ohm. After we have received and we have find out the value for our resistor, we insert it into the circuit as shown in the left side, and we got the result of the waveform on the right side. This is the calculation of active low pass filter, which is for the V out, so that we can find the voltage out. Okay, now I will move on to rectifier. A rectifier is an electrical device that converts alternating current, or known as AC, which periodically reverse direction to direct current, or known as DC, which flow in only one direction. Rectifier have many uses, but are often found serving as component of DC power supply and high voltage direct current power transmission system. This is the circuit for our rectifier on the left side, and we have instructed to use a one micro capacitor as to filter out the noise. Now I will be pass my presentation to Su Yin-san. Thank you.
Okay. Hi sir, my name is Su Ying San. So now I want to present about the voltage regulator. A voltage regulator is an integrated circuit that provides a constant fixed output voltage regardless of a change in the load or input voltage. This is the circuit diagram for the voltage regulator in our project. It is an OM shunt voltage regulator circuit, and the Zener diode in this project is 1N5227B. The Zener voltage for this diode is 3.6 watt. The output for this circuit is 5 watt. This is the calculation for the voltage regulator. VR equal 1 plus R1 per R2 times Vz. Vz is the Zener voltage, is 3.6 watt, and the required output is 5 watt.
After calculate, we can get the value of R1 and R2 is equal 1.4 kilo ohm and 3.5 kilo ohm. That's all from me. After this, I will pass to my partner Rewa to continue the next part. Thank you.
Thank you, sir. I'm Revati Kalimutu. Today I wanted to explain about load, an electronic device designed to provide a load to the output of a power supply, usually capable of dynamic loading and frequently programmable or computer controlled. The electronic loads help designer to test electronic power product and ensure quality, reliability and performance. Next, this is the circuit we use for the load, and we use RLS 25 ohm, and we get 1 watt, and the I we got is 200 milliampere. Next is this is the formula which I get the 1 watt, which I use power out equal to IRL, and we got 1 watt. Thank you. Next, my friend Ami will discuss and conclude this assignment.
Okay, thank you, my friend Revati. And hi, my name is Muhammad Amiruddin bin Rosli, and I'm here today to discuss about discussion and conclusion. For discussion, as the discussion during the constructing the circuit for the project, the student have learned about the basic electronic system circuit such as Wien bridge oscillator, summing amplifier, active low pass filter, full bridge rectifier, and voltage regulator with load. For when bridge oscillator operation, the circuit is in the oscillation mode and the base current of the first transistor is changed randomly because it is due to the difference in voltage of DC supplier. Next, for the active low pass filter circuit, its principle of operation and frequency response is modifying, refreshing, or rejecting all unwanted high frequency of an electrical signal and accept or pass only those signals wanted by the circuit. Then, for operation of full wave bridge rectifier during the positive cycle of DC, the AC input, the upper corner of the bridge is comparatively positive where diode D1 and D2 are connected. In addition, the lower corner of the bridge is comparatively negative, where diode D3 and D4 are connected. Next. After that, such as shunt type linear regulator, here the control element is a series R1 and a transistor Q1 in parallel with the load. In such a regulation is achieved by controlling the current probe Q1. When output voltage try to decrease due to change in either the input voltage or load current temperature, the attempted decrease is sensed by R3 and R4 and applied to non-inverting input of the op-amp. Finally, we can compare the assignment report activity and from theory class with more understanding in our topic from electronic system. Also, have such this assignment report work with the hard working of the team member. So this is a circuit based on block diagram using multisim. This is all that we combine circuit which is oscillator 1, oscillator 2, next rectifier. After that we combine it with voltage regulator, and one more thing is active low pass activator. For the conclusion, in this experiment, we have learned how to construct the simulation circuit and we are able to determine the value of the component for our circuit that we construct using multisim software. We are able to understand the function of the component that we use to create the simulation circuit in multisim software. However, we know how to calculate the circuit using the formula that given to find the output and compare with the simulation output waveform. Lastly, last but not least, we know how to find the output for our circuit using multimeter or electronic oscilloscope to compare with the calculation. That's all from us. Thank you.